Traffic Lights Lab by Urmi Kumar. In this lab, you will need 250 milliliters of distilled water, 5 grams of 6-molar NaOH, and 3 grams of glucose. Later, you will use indigo carmine as your indicator. Please take a moment to read through all the safety instructions for this lab. To begin the lab, add your glucose into your distilled water, and then add your 6-molar NaOH to the solution as well. Next, add a few drops of the indicator, indigo carmine, to your solution. Once done, cork your flask and give it a few gentle stirs. It will take about 10 minutes to turn a yellow color. We see that now the solution has changed to a yellow color. We begin by shaking the solution, and almost instantly it turns a vibrant orange red, and as we continue to shake it, it becomes redder. After vigorous shaking, the solution lightens to a lime green that is only maintained by shaking the flask. The instant that we stop all movement, the solution returns to a red-orange color, and later a red. As the solution completely stills and all movement is stopped, it returns to its original yellow color, but this happens very slowly and may take a minute or two for the reaction to be completed. The most obvious chemistry would be oxidation and reduction. To review, we added the indicator, indigo carmine, which is both a pH and a redox indicator, into the basic NaOH solution. Indigo carmine is blue at a pH below 11.4 and yellow at a pH above 13. As the indicator started as a blue color, it quickly turned yellow as it entered the NaOH solution, which had a highly basic pH. But the redox indicator was also oxidized by the glucose, which is why it first turned a yellow color in the solution, as yellow is the color of its reduced state. When we shook the flask later, we added more oxygen into the solution, oxidizing the indigo carmine. It turned red, an intermediate state, and after vigorous shaking, reached its most oxidized state at green. This experiment, while being a reversible redox reaction, also is an oscillating reaction, where the concentrations of the products and the reactants change periodically. It involves autocatalysis, where the product of a reaction step acts as the catalyst for that same step. This catalyst helps overcome the activation energy and causes the reaction or color changes that we see to happen very quickly. Oscillating reactions have complex reaction mechanisms, which is why they are not shown in this video. The equation above displays indigo carmine's initial contact with glucose. This is shown by the two H+, which reduce the indigo carmine and cause it to turn yellow. Thanks for watching!